Alright, so now we're going to look at function notation and evaluating functions. So that's what today's video is on. So we're still in 1.3, because this is the 1.3 notes. So function notation, again, function notation, we typically use f of x, right? F of x is the symbol. So that's the symbol that we have here at the beginning. So this is the symbol f of x. It's read, f of x is also could be read as the function value at x. F at x is another way to read it. And so it represents real numbers. Functions are always involving real numbers. You can only plug real numbers in, and you can only get real numbers out. And so the real number is the range of the function, right? The real number that comes out, that's my range, of my function corresponds to some real number domain value. And again, it's always real numbers. The symbol is just indicating that input-output sort of model. That's what the symbol is sort of indicating. So my y that's paired with my x is y equals the function. Alright, y equals the function value at x. Alright, y equals f of x. Alright, so it's the value of the function at x. We would write the ordered pair because it's a relationship between the x value and the y value, the function value. Alright, is the ordered pair x comma y, which y is the function value. Alright, so our ordered pair belongs to our function where x again is a real number. Alright, now this last statement sort of, well, functions can have values where, again, we're going to talk about domain in a little bit. Functions can have values that are not in the domain. Alright, and that can happen, right? If I try to plug a value in and it causes division by 0, right, there's an error, that value can't be in my domain. Right? Or if I get an imaginary number, it's not real. That value can't be in my domain. And so whenever that happens, whenever I have an x value that I can't plug into my function, can't put in as an input, what we say is the function is undefined at that x value, or we can also say the function doesn't exist at that x value. And that can happen, right? There are parts of functions where we may have values that don't exist, that are undefined. And we'll talk about that. Actually, we're going to get into domain and figure out those things in this set of notes. We're going to kind of get hit it. Just a reminder, function values are input, output. It's a machine, right? And so the function expression is we plug something into my function. Right? So the input, we plug some x value in. We do a rule. The rule is the function. And after we do the rule, we get a unique output for that input value. And we get one, a single output value for that one input value. So an application example to just kind of look at the relationship, right, using a table example. Alright, lightning, right? If you've seen lightning, you've been out during a storm, you should notice that when lightning flashes, it's followed by thunder. Right? Now, they actually happen at the same time. The lightning causes the thunder. But because that light travels faster, you see the lightning before you hear the thunder. And a lot of times, again, it's often used, well, you use how long it takes for the thunder to be heard after you've seen the lightning to figure out how far away the storm is. And how far away was that lightning bolt? There's a relationship there. And as it turns out, that relationship is a function relationship. Alright, and so that's the example we're going to look at. Alright, so in the table, it lists the approximate distance y in miles between a person and a lightning bolt. When the time elapsed is in seconds. You're counting seconds between when you saw the lightning and when you hear the thunder. Alright, so x represents that time, the time between the lightning and the thunder. Whatever that time is, that time tells you how far away the storm is, how far away the lightning was when it went off. Alright, and there's the relationship. So the time is telling you the distance. So time is the independent, right? You have to figure out the time before you can figure out the distance. So the distance depends on the time. Alright, and so here's my table. My x value is my time in seconds, so we counted 5 seconds represents 1 mile. So if you count 5 seconds between the thunder and the lightning, 1 mile away. 10 seconds, 2 miles away. 15 seconds, 3 miles away. 20 seconds, 4 miles away. 25 seconds, 5 miles away. Alright, and so the table established a function relationship between x and y. Alright, it is a function. The reason why it is a function is because it satisfies the following information. First of all, each x determines exactly 1 y. So if you look at the table, for this 5 seconds, there's one distance that goes with it. Right? After 5 seconds is a distance of 1 mile. 10 seconds is a distance of 2. So there's only one y value for every x value. There's only one distance for every time elapsed. Right? And the function, what it finds is it computes the distance between the observer and the lightning bolt, right, with given the time. So we say y is a function of x. Alright, now we're going to actually do the function. So that's the description, and so now we're actually going to find it. So what is the function? So the y can be found, and you look at it, math is a pattern. Alright, so we're going to be looking at, math is just looking at patterns. So I want to come up with the function rule. So if I look at it here, 5 seconds elapsed, I have 1 mile. 10 seconds elapsed, I've got 2 miles. 15 seconds, I have 3 miles. If you notice, for every 5 seconds, it goes up by a mile, right? The first 5 seconds is 1 mile. The second 5 seconds, it's now 2 miles, right? It goes to 10, right? And 15. And so what the rule is, we can find our distance, our y value, by dividing the x value, the time, by 5. So you take your seconds, divide it by 5, and it'll tell you how far away the lightning was in miles. All right? And so the function rule is y equals f of x, where we have x divided by 5. That's our rule, and you can check to make sure it works. Plug in our values. If I plug 1 in, right, if I plug the x value 1, or not 1, I don't have an x value 1, x value 5, I'm going to get 1 out. Alright, if I plug 5 in for x, alright, I'm going to get 5 divided by 5, which is 1, and that is correct, right? I plug 5 in, I get 1 out, right? The x value 5 is paired with the y value 1, and I'm going to check the rest of them. Actually, I'm just going to check a couple more. I'll do 10 and 20. Alright, so I'm going to check the x value 10. So f of 10, plug it into my equation. 10 divided by 5 comes out 2. Alright, and that checks. The 10 seconds is paired with the 2 miles, and then we'll check 20. Alright, so f of 20 is 20 divided by 5, which is 4, and see if that's true. When x is 20, we should have had a distance of 4 miles, and it does. 25 and 15 work too. You can check those out, but it works. That's the function, and that's the relationship in the function equation. Alright, so now we're just going to practice evaluating functions a little bit. Again, this really should be something you've done many, many times before in the past. I'm just reminding you how to do it. So evaluating means solve. That's what we see the term evaluating in math. Evaluating means solve. So we're going to solve the following function. Alright, so we have the function 2x squared plus x minus 1. Find the values of the following. Alright, so the first one is f of 1. And so what we're looking for is we want to find the y value when x equals 1. Alright, what's the y value? Well, I plug it in. And it goes in the x spot. So it's going to be 2 times 1 squared. So I just replace x with 1. So 2 times instead of x squared, 2 times 1 squared. Plus 1, minus 1, and then we follow order of operations to simplify. Or you plug it in the calculator, just again, make sure you follow order of operations. When you do, when you plug it in, it comes out 2. Alright, so the y value is 2. So f of 1 equals 2. Alright, where when I plug the x value 1 in, I get the y value 2 out. I do the same thing for negative 5. So same thing here with negative 5. I want to find my y value. My x value is negative 5. So I'm going to take 2 times, and be careful, it's negative 5 squared. Make sure you put parentheses around this negative 5 so you remember to square the negative. If you don't put parentheses here, you'll get the wrong answer. Alright, plus a negative 5 minus a 1 equals. So again, make sure you're careful. This is going to give me out 10. So I'm going to get 10 times 2 minus 6. Or not 10 times 2. I am multiplying 5 by 5, so 25 times 2, which is 50 minus 6, so 44. Or again, you can plug it into the calculator. So the y value, 44, right? X value 5 paired with the y value 44, so f of negative 5 equals 44. Right, next example. Next example is a little different. Right, this is when I'm taking a function and plugging in another function. It really just comes down to simplifying. So this time, I'm going to replace x. So it's not really equal to. I'm going to replace x with 3 times x. right, in my function. So everywhere there was an x value, I'm going to replace it with a 3x. So instead of 2 times x, it's going to be 2 times, and in the grouping symbols, 3x squared plus 3x minus 1. And then I just want to simplify. So really in this one, I'm going to get a whole new function is what happens here. Right, and so simplify this. First thing you do is square, and make sure you're careful. It's 3x times 3x, so I get 3 squared and x squared. Alright, this is going to give me 9x squared, when I square those, plus 3x minus 1, 18x squared plus 3x minus 1, and then that's it. There's no like terms, right? I can't add a square to the x and negative 1, and so there's my new function. It's a new function, which will give me out new y values. Alright, so it changed my original function from 2x squared plus x minus 1 to the new function 18x squared plus 3x minus 1. Alright, the last one, I want to find x given f of x equals 2. So we know the y value is 2. We want to find the x value that's paired with it. And so this is solving a function. So I want to set my function equal to 2. Well, my function was 2x squared plus x minus 1. Alright, there's a couple ways to do this. Alright, you can solve it graphically. You can solve it by hand by moving the 2 over, setting equal to 0, and using the quadratic formula, and that's fine too. It also factors. You could solve it by factoring, set it equal to 0 and factor. And so it's just up to you however you want to solve it. I'm going to solve it by graphing, right? So I'm going to solve graphically. Or I'm going to solve, maybe I won't solve graphically. Maybe I'll solve it by hand, by factoring. Alright, so solve it by factoring first. So first thing you do when you solve it by factoring is set it equal to 0, so move the 2 over. So I get 0 equals 2x squared plus x minus 3. You could also use the quadratic formula. Remember the quadratic formula, opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Alright, where those numbers come from, a is with the x term, b x squared term, b is with the x term, and c is the constant. Alright, and you can do that. You can plug it in there and solve for your x values that way. I'm actually going to factor these since 2 is prime and negative 3 is prime. Right, the only way to split 2 up is 2 and 1, so I get a 2x and a positive x. There's also a box method, and if you know the box method, that's fine. I'm going to use the guess check since it's prime. 2x squared can only be split up into 2x and x, and then my negative 3 can only be split up to 3 and 1, and one of them's got to be negative. Alright, so 3 and 1. And so I'm going to try negative 1, positive 3, and then I'm going to check. Alright, what your check is the guess, and my check is I've got to multiply these numbers and see if they add up to the middle value. So when I multiply 3 times x, that's going to give me 3x. When I multiply 2x times negative 1, that's going to give me a negative 2x. When I add those together, I do get the x value in the middle I want. So my guess is correct. Alright, so again, guess check. And then what you do is you use the zero product property, which means 2x plus 3 can be 0 or x minus 1 can be 0. Solve this, so move your 3 over. 2x equals negative 3, divide by 2. X equals negative 3 halves. You can see that. X equals negative 3 halves. And then over here, I'm just moving the 1 over, so x equals positive 1. Alright, so there are 2 answers. But that's okay. It still means it's a function. So basically what this means is there are 2 x values that's going to give me out the y value too. If I plug in 1 into the function, I should get out 2 for my y. And if I plug in negative 3 halves, I should also get 2. It's still a function though, because I'm only plugging one value in and getting one value out. I just happen to be getting the same value at 2 different x values. And again, that's okay. Function values allow me to do that. The biggest thing is one value in gets me one value out. And so there are two solutions. And we'll do more. This was sort of just, again, kind of a quick talking about functions here. We'll do more with solving in this case later on when we get to quadratics, which is a whole nother chapter. And we'll go over again kind of how to solve these one more time using. So there's actually three ways to solve a quadratic, right? Graph it, which I didn't go over. Quadratic formula, which I gave you, which again you should hopefully are familiar with quadratic formula, and factoring. Factoring is the way I decided to go. Alright, so we'll stop the video there, and we'll pick up the next section on the next video. I don't know why I'm erasing it, but I just felt like erasing it. Alright, so I'm going to pick up this on the next video.